Hello everyone, we are going to solve another LeetCode problem, which is reverse bits of a given unsigned 32-bit integer. Okay, uh, we have to reverse those bits, and if you see the example here where we have given number n, and we have to reverse it. As soon as we reverse it, it has to be 10. If you see, this LSP bit is 1, which becomes my MSP bit, and the second last bit from LSP side becomes my MSP bit 0, and the rest all 1 becomes my LSP side here, if you see here. Okay, so now if I take an example how we can solve this problem here is by taking a simple example. Okay, so let's suppose if I have n which is 10. Okay, so if I take n, if I make it n equal to 10, which is nothing but 1 0 1 0, which is nothing but if I make it 1 2 4 8. Okay, so if you see, this is 8 is 1 and 2, which is my 10. Okay, but if it is, since it is 32-bit number, so if I make it 32 bits, so this is nothing but all 4 zeros, 8 zeros, 16 zeros, 24 zeros, and the last 4 is nothing but 0 1 0. So this is my 32-bit number. This is how the number input we have got. Okay, so if the output, if I say here, is the output has to be like 1 0, no, sorry, 0 1 0 1 0 1, and the rest all zeros. Okay, so this is how the output we have to return. So how we will achieve this is, okay, so what we do is, wherever we have 0 bit, okay, we will simply left shift our number, the new number which we are going to form, the reverse number. Okay, if it is, if we get the LSP bit as 1, we always XOR 1 into a number. So okay, I'll write the pseudocode here. So I'll take unsigned integer int number, which is 0. Now while, okay, we'll have index 1 index, we'll also take index int 0, which is less than 32, because we have to run a loop to all 32 bits. Okay, so our index is 0. Now what I said is, this number we have to always left shift by 1. Okay, because we have to make it complete 32 times left shift, right? And the LSP bit we have to set based on whether our LSP bit is 1 or not in given number. So let's suppose if and 1 equal to 1, okay, it's always check my LSP bit. Okay, LSP bit is 1, then we have to simply XOR that to our number, else we simply left shift our number and index plus plus. Okay, then return number. Okay, so if I take this example, very simple, I'll just simply take this number only. Okay, this much only, I'll not explain the rest of the 0 here, but okay, this is my number. So my number is what, initially 1010, sorry, my n is input given is 1010, and my number is, so I simply take 4 digit, which is 00. Okay, so first time we, our index is, while loop is true, yes, true. What we do is, now we come inside loop, we left shift our number by 1. If we have all 0 and left shift by 1, this again becomes our 0000 only. Okay, so this is nothing but 0000. But now if we add our number n with 1, okay, so it is nothing but 0001. If I add this with like this, what you will get? All zeros. Okay, this condition false, will not go inside this if check. Okay, will not go inside this check. We simply right shift by 1. Okay, our n, so n value is this guy. Okay, so now new n is nothing but 0101. Okay, now index is plus plus now, so index is now, I'll also take this index here. Index earlier it was 0, now it is 1. Okay, so when it is 1, now we simply again left shift our number by 1. So number is still, if you left shift by 1, this guy, so this guy is still 1 only. Okay, now this time if we add this our n input n with 1, what we will get? We will get 1, which is non-zero value, which is equal to 1. Okay, now this time what we will do, just XOR our number, sorry, XOR our number with 1. So if I just XOR this number with this guy, so when you do XOR, okay, so if the bits are similar, the output is 0. If the bits are different, the output is 1. Okay, so this is our number now. Okay, now this time again we have to right shift our and input n by 1. Okay, so what is our input? This guy. So if I again left shift by 1, this is nothing but 0010. Okay, this is my n. Okay, so and index is now 2. Okay, so now again, so we just simply left shift our number this time by 1. So as soon as we left shift by 1, the number become 10. Okay, this time when we do AND operation with my checking whether LSP bit is 1 or 0, this time this is 0, will not do anything, no operation performed here. Okay, so this is 0. Okay, now we simply left shift our number by 1, so our new n is nothing but 0001. Okay, this is our new n, and my index is nothing but now this time 3. Okay, and I simply left shift again, so this is, if I left shift again by 1, this is 100. Okay, number, and this time if I do AND operation with this guy, which is again condition is true this time. Okay, so once the condition is true, we do XOR operation here with by 1. Okay, once you do XOR operation here, so this become 100101. Okay, so and index is now 4. Okay, but the number is not, this time is 0. Okay, so we will not do XOR for rest of the bits here now, but we simply keep on left shifting our this bits till our index is 31. Okay, so if you just keep on left shifting this byte, so it becomes our like 0101, and the rest all zeros. Okay, so this is what our output. Okay, so now if I go and simply write a program here. Okay, so I'll take integer index equal to 0, and 32 underscore t number. I'll take like reverse equal to 0. Okay, while index less than 32, yes, it is less than 32, we simply reverse number, we simply left shift by 1 always if we get LSP bit in our given number as 1. If LSP bit is 1, we simply XOR our reverse number by 1. Okay, else in the sense, other than that, what you can do is you simply do index plus plus, and before that we simply do our and also left shift right shift 1. Okay, and then simply we do return rev. Okay, so that's it. So what he's saying is expression to silence that warning. So he wants to put it into parenthesis, this guy. Okay, yeah, so yeah, that's all. And submit this code. Yeah, so that's all in this video. Thank you for watching.